Okay, so today we begin section 3.6 where we're graphing from slope-intercept form. Now today is going to be a very good day for most of you because graphing in slope-intercept form is one of the first forms of line that we learn to graph. It's also one that they've covered in Math 8, they covered it in Math 7, and they covered it in Math 6. When we're looking at finding slope, that was even covered all the way back into Math 5. So this is something they've seen over the past several years. This has been Math 8, 7, 6, and 5, so the past 4 years. If they took Algebra 1A, it's been for the past 5 years. And then graphing and slope, you've got Math 8, 7, and 6. And then if they took Algebra 1A, also 4 years worth of content. So it should be really familiar. We're just knocking the dust off this one. So let's take a look. Slope-intercept form is, we need a starting point and a rate of change for most, like, let's see, where are we tracking our progress from here? So I need somewhere to start my line, and then how do I move it? How far up, how far over, or how far down and how far over am I going? So we call those two things the slope and the intercept. That's in the form of y equals mx plus b. The b is our starting point. That's also called the y-intercept. It doesn't have anything attached to it. It's just a number. The other part of it is the mx, or the letter or the number in front of the x. What we call the m is our rate of change, or what we call the slope. So those two terms, when you isolate the y, you have a term with an x and you have a term that's just a number. The term that's just a number is where you start. The term with an x is how you move after you start. That's basically it. So let's make sure we understand the concept of what a slope is before we jump into slope-intercept. Now, a slope is usually defined in math by the letter m. Now, the m is defined as the rise over the run. Again, how far up or down are we moving versus how far over are we moving? Am I eating 2 pizzas every hour? Am I eating 2 pizzas every 5 hours? Am I eating 3 pizzas every hour? Or am I eating 10 pizzas every 10 hours? You know, what is the rate of change that we're going to go through that? And the rise is going to be our change in y, change in height. The run is going to be our change in x. And we remember, big change is big delta, so delta y over delta x. Or if we're looking at the change in y, the difference between two y values or the difference between two x values. Now, this is a really long equation right here because it's been rewritten several times. For the most part, this part of the equation you're going to use when you're graphing, because all it involves is counting. So when you say, hey, what formula did I use? I'm going to say either slope equals or m equals rise over run. There should be a graph attached to it like numbers 1 and 2, and I'm going to count. If there isn't a graph attached, let's say I just have the coordinates, which we'll do here in a minute, I'll use the difference value in here. So this is if I just have coordinates. Okay. And lastly, if I have a table, mostly I'm going to be using the delta y over delta x. So this is our table method. Now, any of these, if you want to take some coordinates and graph them and use the rise over run, you can. It's going to take a minute, but you can still do that. If you want to use the table and turn those into coordinates in order to graph them so you can use rise over run method, you can. It's going to take you a little bit longer. But any of these methods can be substituted with any of the other ones. But again, these are the fastest methods for those problem sets. You can flip-flop through these, but I'll show you how to do these. First and foremost, let's take a look at number 1. We want to find the slope. Now, we said with graphing, the easiest way to do it is just say rise over run. So we have to define what formula am I using here. So I'm going to say, hey, the formula that I'm using is slope, which equals the rise over the run. Okay. Now, with the rise over the run, I'm going to say, okay, from the left to the right is how we measure slope. So from the left point to the right point, I'm going to see how far up or down did I have to go. And if I count up 1, 2, 3, 4, I went up 4, up 4. Now in math, we define up as a positive direction, down is negative. So this is a positive 4. Next, I have to define what is the run. So that means from the top of that line I just drew, how far over do I have to go to get to my next point? So that's 1, 2, 3, 4, 5, and 6. So we see the fact that I went up 4 and I went to the right by 6. Now left and right, left is negative, right is positive. So when I say right 6, what I'm doing is I'm saying plus 6. So if I look at this, I know the slope that I have is a 4 over a 6. So my slope doesn't divide evenly, but it does reduce. Both those divide by 2. I'll get a 2/3. Okay? So that's what we call the graphical method. I just use rise over run. I'm not using the rest of this. I'm just saying my slope, or my m, is rise over run. I should have a graph attached to that, and that's all I need to do. So let's do one more where we use that method. So if I use the rise over run, from the left to the right, I'm going to say I didn't go up this time, I went down 1, 2, 3, and just 3. Passing my point there. So if I went down by 3, I know that my slope, the version of slope that I'm using, is the rise over the run. And I went down 3. Now, if up was positive, down is going to be negative. Probably should have done that in blue to be consistent, but oh well. You guys get the idea. So I went down 3, and then I'm going to see from the tip of that line I just drew straight down, how far over do I need to go? Well, I went over 2, or to the right by 2. So right, 2, okay? And if right is positive, right is again positive. So I have a positive 2. So for this one, I have a negative 3 over a positive 2. So the slope of this line is a negative 3/2. Now I brought the negative out front because what that does is that allows me to see that, hey, the slope is in fact negative. I'm going in a downward direction from the left to the right. And we can see that line goes down from the left to the right, where this line went up from the left to the right. So this is a positive slope. That's a negative slope. Bingo. Now, one of the things I ask is I'm like, okay, let's assume that I didn't have the graph, but I have the same information presented to me. What happens if I only give you the coordinates of these pieces without a graph? And I say I give you negative 3, negative 2, and positive 3, positive 2. Okay. So let's just assume, okay, different problem set. Basically, I have my negative 3, negative 2 right here, and my positive 3, positive 2 up there. I gave you the same coordinates, but instead of giving them to you in a graph, I just gave you the values. Likewise, I could do the same thing over here. How about I give you the coordinates 0, 2, and the coordinates 2, negative 1. So I give you 0, 2, and 2, negative 1. So how would I solve that? Well, like I said, one of the best ways about finding slope is you can switch between the different production methods. I can take those coordinates and graph them and do what we just did and be done. I need graph paper. It might take a minute, put the graph down, put the points there, make sure you're counting correctly, and then count again correctly. Not hard, it just takes a little bit of time. But there's a faster method. I can use this part of the formula to figure out what the coordinates are. So I'm going to say, okay, here my slope is y2 minus y1 over x2 minus x1. I can use that. I just need to define what is y2, what is y1, what is x2, and what is x1. So I think this causes for a slight aside. What I'm going to do is I'm going to pause the video, show you a little bit about how we do subscript and superscript notation, because this is something a lot of students get a little mixed up. So pause real quick while I change boards. Okay, so here we have how to do superscripts and subscripts. What a superscript is if I say I wanted to square something. So I'll go, okay, I have an x and I'm going to square it. I put the script at the top right of where the letter ends. If I have a capital letter like the letter M, what I do is I say this is M squared. I put it in the line where the letter stops being written. So that works with a lowercase or an uppercase. If I have something that's like a line and a half, let's say the letter B, something like that, I'll still put it, imagine that there's a line right there at the top of the B. Subscripts always go through the base of the letter. So if I say, okay, I want the letter X1 or X2, if I have something like a capital letter M1 and M2, or even if I had something like a Y. So if I say Y1 and y2. It always goes through the bottom line of where you're writing. So this is a superscript, this is a subscript. Superscripts we know as exponents. This means b times b. This means m times m. This means x times x. So what do you think a subscript means? Well, almost every class said, well, let's do division. If this is multiply, this should be divide. We already know how to do division. If I want to say don't multiply by b twice, divide, I just make that a negative. If I say don't multiply by m twice, divide by it, I just make that a negative. So negative exponents means division. All these are name tags. So the idea is that when we start having multiple values, like let's say here's an x, here's an x, and here's an x, I need to define which one's which. So I just give them name tags. I say this is the first one, this is the second one, this is the third one. That's all they are. You're not doing anything mathematically to them. And the joke that I make is no matter how many x's you have, 4, 5, they're just name tags. They don't do anything mathematically. In fact, I can even have one that looks like this, Mr. Johnson. And this is the point I get across, is I'm like, okay, this is your first x, your second x, your third x, your fourth x, your fifth x, and this is Mr. Johnson's x. We don't talk about that one. And they get a laugh, but it gets the point across that we don't do anything with these numbers. The big reason why we take this aside to go through this is because often what I see is I'll see students do something like this, and they'll say, oh, I must be multiplying x times 2, when what they really meant to write was they meant to write something like this. Okay, we don't want to do that right there because that is confusing. It's always a smaller number on the bottom line. So let's go ahead and let's jump back to the board and get this finished. Okay, so now that we've seen how to write these things, I'm not multiplying y times 2, I'm not multiplying y times 1, I'm not multiplying, I'm not dividing, I'm not exponentiating, I'm not doing anything to the 2 with the x, that's just the name tag. So, okay, well what do I do with that? Well, I need the second y and I need the first y in order to work out this formula right here, because I'm subtracting the difference right there. So how do I do that? Well, in order to figure that out, I need to label these things. And so I know I have two coordinates. I always ask myself, what comes first in a coordinate? Does the x come first or does the y come first? About half the kids remember at this point. I get x, I get y. Some classes are better than others, but for the most part, they don't really remember. So what comes first in the coordinate? Alphabetical order. It's what we call alphanumeric order. What comes first in the alphabet? P, Q, R, S, T, U, V, W, X, and then Y. So what we know is that X always comes first before Y in the coordinate. Same over here. X comes before Y, and if I throw a third one in there, that would be Z or Z, depending on where you're from. Now, all I need for these is I just say, okay, from the left to the right, what's the first X I see? Oh, this is my first X, this is my first Y. This is my second X, this is my second Y. Bingo. That's it. That's all I need to do. Okay, so if it's Y2 minus Y1, my second Y is 2. My first Y is negative 2. X2 minus X1, my second X is 3. My first X is negative 3. Done. Okay, I just solved whatever this works out to be. And so I say, okay, what is minus a negative? Class is really good about this. They're like, oh, that's plus a positive. So 2 plus 2. And then over here I have, what does minus a negative end up turning into? Plus a positive. They're like, well, that's 3 plus 3. And at this stage, we kind of devolve into, sorry about that. At this stage, we kind of devolve into the kids see 2 plus 2 and 3 plus 3, and they kind of lose it because they're like, oh, this is simple, Mr. Johnson. Like, this is easy. Why are you giving me this easy stuff? But again, this is the hard part, is remembering how we label these things, but they have seen it before. So if they're getting it, awesome. So the 2 plus 2 is going to give us something that says 4. 3 plus 3 is going to give us 6. So as of right now, I have my slope is 4 over 6, which does reduce down to 2 over 3. So we can see the fact that if I have it graphed or if I have it numerically, both of the rise over the run and this part of the formula give me the same answer. So this isn't one big formula that you got to do all of. It's basically a giant key where you're like, I want to do this part. I want to do this part. I want to do this part. Find the part that's easiest for you. And again, if I took these and I graphed them, I'll get the same answer. So whatever's easiest for them. On their homework, do they need to do both methods? No. Pick the method that's most appropriate and the easiest for them. So that's all that I require. On this one, I did ask them to try this out themselves. So I'll give them a moment. If you want to try, pause the video, give it a shot, see how well you do. I'm assuming you've paused it at this point, so I'm going to go ahead, I'm going to start doing it. So what I'm going to do is I'm going to say, hey, I have the formula for slope that I'm going to use is my y2 minus y1 over x2 minus x1. Okay. I need to identify what variable is what. Okay. Well, I know according to the alphabet, x comes before y. And I know this is my first x and my first y. This is my second x and my second y. So when I start plugging these things in, let's see, I have something minus something. I go from the left to the right, so I've got, okay, y2 minus y1, that's negative 1 minus 2, negative 1 minus 2. x2 minus x1, that's going to be 2 minus 0. So if I come down, I have my slope is going to be negative 1 minus 2 is going to give me a negative 3. 2 minus 0 is going to give me a 2. And bingo, there's my slope. So I see I get the same answer no matter if I'm given coordinates or if I'm given coordinates visually. They do the same thing. And now, at this point, I also highlight, I'm like, hey, one of the big things that you're going to have to start doing, because it's a big thing in geometry next year, is they're going to have to start dictating what formula did I use. Did I use this method? You have to tell us. I used slope, which involved this equation. Here I used slope, which involved this equation. They both give me slope, but which one did you use? Because in geometry, they're going to start doing this thing called a proof, where they have to write the formula down, name the formula, define the variables, then plug them in. All we do is we write down the formula, then plug them in. We're not defining them. We're not naming them yet. We know that they have names, but we're trying to get them ready for next year when they get that thing, because students tend not to like it if they're not prepared to show their work. And yes, I know it's high school and some of them still have problems showing their work. So far so good. Let's jump over to one that uses a table now. So pause while I switch screens one more time. Okay, so here we're finding the slope using a table, and we're going to be using a slightly different version of the formula. Now, one of the big things, if you look in the book is going to use the y2 minus y1 formula each way, but we've already gone ahead and we figured out what delta is, and I think delta is going to be a much faster method to use. So let's go ahead and get that started. So the formula that we want to use on here is we want to say, hey, I'm defining slope, which instead of writing the word slope, I'm just going to write how we normally write it, m. So I'm going to say m equals, I have the change in y divided by the change in x, which we show as delta y over delta x. Okay, so what do we do to find delta y and what do we do to find delta x? Well, when we look at the table, I say, okay, delta y is the change in y. And what we did last time we had tables, we looked to make sure that we had either a linear or nonlinear equation. So I said, let's take a look at what's happening to the y. Well, I went down, down, down. And remember, we defined down in math as a negative. So I went down by 6 from 20 to 14. I went down another 6 from 14 to 8. I went down another 6 from 8 to 2. So I have a constant change in y. So my delta y is a negative 6. Then I do the same thing with x, and I see, okay, what am I doing with my x? Well, each time here I'm going up, 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 or to the right, to the right, to the right, depending on how you look at it. So I see the fact that I'm going up, 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 and I'm going up by 3 each time. So I have a constant rate of change. So my delta x is a positive 3. That tells me that my slope right now is negative 6 over positive 3, which reduces to either a negative 2 over 1 or just a negative 2. Now, depending on what type of problem set you get, If it's a computer-based, like either on the EOC or some of the Delta Math things, which I've tried to pick out so that they read these, it either will ask, give your answer in simplest fraction form, which means I'd put -2/1. I leave it as a fraction, but I fully simplify it. Or if it just says, put your answer in simplest form, I just say, okay, -2. So just be careful on reading and saying, what does the computer want me to plug in? Because a lot of students will lose points, specifically on the EOC, because they're not plugging in the right form of the answer and the computer doesn't recognize what their answer is. So I don't care which one, if it's on paper, if you get one of these two. But again, on the computer, make sure we're reading and paying attention to that finer print. Now, what does this mean? Well, this means that my rise is a -2, my run is a 1. So what this graph is doing is I'm going down 2 over 1. So it looks like I am heading in a downward direction. This is a negative slope or a negative line. Okay. If I look at number 4, I'm going to try and do the exact same thing. I'm going to say, okay, m equals, I have a change in y divided by a change in x, which I use change to represent with a delta. I have delta y over delta x. So if I look and I say, okay, what am I doing to the y's? And this screwed up some of them because they're like, well, there is no delta y, so therefore empty set, which is good thinking. But it's not that there isn't a change in y, as in that there is no change in y. It's that y is staying constant. Is it going up or down? No. So it's neither negative nor positive. So when I ask them, what number do you know of that is neither negative nor positive? Light bulb comes on. 0. They're like, oh, doesn't change, doesn't change, doesn't change. Delta y must be 0. And they're like, yeah, they get it. So they're doing some critical thinking here, but they said, well, empty set. No, this does have an answer. The answer is 0. It's not that there is no answer. The answer is that there is no change. Okay. Now with delta x, let's take a look at this. Here I have a 2, a 2, and a 2, which means I have a consistent 2. Okay. So if I want to show my answer in fraction form, I would put a 0 over whatever number I wanted because it doesn't matter. Because what is 0 divided by anything? 0. Okay. So with 0, well, what does that mean? That means I have no rise, but I have all run. So what does that look like? So if I don't rise, but all I do is I run over 2, well, from my start to my finish, like in here I had my start and my finish, I have a horizontal line. Okay? The line is flat. There is no rise. It is a 0 rise. It is only run, which means I'm only going to the side. Okay? The last one, I encouraged them. I said, hey, take a moment, try out the last one. Go ahead and use the same formula and give it a shot. So pause the video if you want to try out number 5 and see how you do. Okay. Now what happened was, if you did pause the video, you'll notice something weird happens on this one. Now it's entirely doable, but when they try and do delta y, they notice we went up by 3 and we went up by 6 and then we went up by 3 again. They're like, pause, I don't have a constant delta y, which means this might not be linear. But here's the deal. This does actually have a slope and it's constant. We haven't actually, I think, gone through how to find when there's a gap yet. But what I like to do is I say, okay, well, if there's no delta y, I can't use that method. But do I have another part of a formula that I can use for coordinates? Because do I have any coordinates? And the answer is yes. I have a y, a y, a y, and a y. I have my first y, my second y, my third y, and my fourth y. Over here, I have an x, an x, an x, and an x. My first, my second, my third, and my fourth. Bingo. Do we see where we're going with this? Yeah. This is going to be the part of the formula where we say, hey, I want to find the formula for slope using y2 minus y1 over x2 minus x1. And here, what we've got is we quite literally have everything labeled. My second y, my first y. So I have 0 minus -3. my second x minus my first x. So I have negative 3 minus negative 3. And as we start solving this, minus a negative becomes plus a positive, so I get 0 plus 3 over negative 3 plus 3. If I take this one step further, 0 plus 3 is 3, negative 3 plus 3 is 0, and then they lose their minds because they're like, okay. I get all sorts of weird answers on this one. I get that it's 3, I get that it's 0, I get that they do some things where they like change the 0 to other things and multiply it and add it and subtract it. I don't really know. But the two most common answers I get is I get 3 and I get 0. Because they see a 3 and they see a 0, they're like, it's got to be one of those. And so I asked them, I'm like, can 3 fit into 0? No. How often can it fit into 0? Well, it can never fit into 0. So a lot of students then jump in and they say, hey, this is an empty set, and they write out this symbol. And I'm like, good thinking. But again, we actually have a name for this, and I know it's a little wonky, but the name for this is what we call undefined. Whenever I take a number and divide by 0, we call that undefined right now because I'm trying to plug something into nothing. And we're not talking about bending space-time and taking our three-dimensional space and folding it into the 0 axis. We're not talking about that yet. That's more college level. Right now, we're just like, can't put something into nothing. Can't do it. Don't know how to define that. Well, what does it mean not to be able to define that? Let's take a look at the graph and see if that helps. I go up by 3. So let's say I start here, and I go up 1, 2, 3, and I end here. Okay? That means that this type of graph is a vertical line. So let's do the vertical line test on these things. The negative means that as I'm moving along, my height is dropping. So I'm like jumping out of a plane here, or sliding down a slide, or my bank account is disappearing. That's negative. That makes sense. Here, I'm basically like sitting in the plane, or my hunger is staying the same, or my bank account is just sitting and not doing anything because there's no rate of change. Here, nothing exists, and then all of a sudden, you are at all points in time. You are above the plane, in the plane, below the plane, in the ground, below the ground, all at once, and then you disappear again. If I'm looking at the amount of money I have in my bank account, I have no bank account. It doesn't exist. And then boom, my bank account is at infinity. It's at 0. It's at 100. It's at 1,000,000. It's at negative 12. It's at negative 1,000,000. It's at negative infinity. It's at all of these things all at once. And then my bank account disappears again. So this is multiple things happening at the same time. So we call that undefined because it doesn't really make sense. Okay. So awesome. Let me actually pause this while I pop these two mats back over here. Give me one moment. There we go. Okay. So these last 4 are like what the homework's going to be about. We're looking at graphing these things using the information that we now know how to do. Okay. I need to identify the slope and the y-intercept and then graph. Well, remember, when we said that we were going to be graphing these things, I need a starting plate. I need to say, okay, am I starting at no dollars? Am I starting at 100? Am I starting at 1,000,000? Where do I begin before I either start making, staying average, or losing money, or some combination therein? I need a starting place, and I need to know how to move. Well, remember, our starting place is our b, the number that doesn't have an x. How I move is the number in front of x. That's my slope. So I have my starting place, and I have my slope. We write it backwards, but that's okay. Let's go ahead and say that. So my starting place is my y-intercept, which in this case is 0, negative 4. Okay? That's where I'm going to begin this journey. This number right here is my slope. So my slope tells me how I'm going to move. So right now I have a positive 3. And now slope always has to be a fraction. I have to have a rise over a run. So I asked them, what number is any number understood to be over? And they're like, 1. Positive or negative? Positive. They all get this. Okay. So what that tells me right there with the positive 3 over the positive 1, my rise is telling me to go up 3, and my run is then telling me to go right 1. Okay. So I'm going to start at that number, and then every time I move, I go up 3, right 1, up 3, right 1, up 3, right 1. So let's go ahead and let's graph this real quick. Now, these top two, I'm going to do standard 5 by 5s. I have an y and I have my x. I'm going to do the same over here. I'm going to do a standard 5 by 5. If you don't know how, just trust me. Okay, awesome. So right here, my starting point is at 0, -4. So my starting point is on my y-axis because this is my y-intercept. And then every time I move, I go up 3, right 1. So every time I move, I go up 1, 2, 3, right 1, put a point. Up 1, 2, 3, right 1, put a point. Up 1, 2, 3, right 1, put a point. And then I connect all these with a straight line. And that's it. That's us graphing. And all we have to do now is label. But the hard part is now done. Bingo. So I've got that. So you can see I have a starting point, which is actually one of the points I always make sure and label. I label 0, -4. And then this point up here is my x-intercept. I always label that as well, which in this case is 1.3, 0. And students ask, and this is usually the thing, how do you tell it's 1.3? I thought it was 1.5. Well, there's a little trick that we'll get better with doing with time. And basically, I know every time I move over 1, I have to move up 3. So if I only moved up 1/3 of the distance up, I only moved over 1/3 of the distance as well. And what's 1/3 of 1? 1/3. So I have 1 and 1/3, which is 1.3 repeating. So bingo, that's where I got that. Awesome. And so at this point, they're like, okay, I got it. Figure out your starting point. So my starting point for my y-intercept is the number without an x. It's 0, 2. Okay. The next thing is I need to figure out what my slope is, and my slope in this case is -5. Now, I know that -5 means I move down 5, but what do I move over? And they're like, 1. And they're like, is it positive or negative? And I get about half of them that say positive, half of them that say negative. Again, it varies by class, but that's typically what I get. Now let's take a look. What happens if that 1 is negative? What does it do? What is a -5 divided by a -1? What's a negative divided by a negative? Positive. Is my slope positive? No. So can my 1 be negative? No. It's got to be positive because that means that negative divided by positive is negative. My sign holds true, so my 1 has to be a positive. So I'm moving down 5 every time I move right by 1. So let's figure out where we're going to start. Start at 0, 2. And then every time I move over, I'm going to move down 5, 1, 2, 3, 4, and 5, right 1. Bingo. Connect those points with a straight line. Last but not least, we label our intercepts. One of my intercepts is my starting point, 0, 2. My other intercept is right there. And again, if you want to just guess, you can guess, but let's start applying this logic. I have moved 2 out of 5 spaces down to my next point, which means I've moved 2 out of 5 spaces to the right. So 2/5 of my distance to the right, which I know is 1. So 2/5 of 1 is 0.4. So that's actually at 0.4, 0. You don't need to know that. It's for later. Okay. Then we take a pause right here where I'm like, hey, feel like you're getting in there? Yeah. I show them these two. Again, weird things happen, but good weird things. Because at this point I say y equals a number. I'm like, okay, we know our starting point. Here I know my starting point. I have the y-intercept. I have the number without an x. It's 0, 6.5. But they don't know what the slope is. And they're like, well, what is the slope? And I either get 0 or I get 1 because I asked the question. I'm like, okay, well, what number must be there if we can't see it? 1, 0. Well, which is it? How many x's do you see? Do you see 1x? No, I see 1y. So if you see a variable, remember, the number in front of the variable would be 1. But you have to see the variable. I see y. What's the number in front of y? 1. Do you see an x? How many x's do you see? 0. So what's the number in front of x? 0. So this must be a plus 0x. And that usually makes sense. They're like, oh, okay, there are no x's, therefore there are 0 x's. So my rise is going to be 0. And my run, what's any number understood to be over? 1, including 0. Any number is over the number 1. That tells me I don't go up or down, I just go to the right. So I have no up or down, I just move to the right 1. So when I graph this, I'm going to move my axis down a little bit, give me some more room. So I'm going to put it right here. Okay. So I'm going to start at 6.5. 1, 2, 3, 4, 5, 6 and a half. Start right there. Don't go up or down, just go to the right 1. So I move to the right 1. Don't go up or down, move to the right 1. Don't go up or down, move to the right 1. Don't go up or down, move to the right 1. Don't go up or down, move to the right 1. What type of line am I graphing here? Horizontal line. If I can actually graph this straight, even with a ruler, sometimes this is a little difficult. Bingo. We label our one intercept point, which is right here, which is at 0, 6.5. I ask them, like, hey, is there an x-intercept? No, because it's a horizontal line. It will never actually dip down. It's just going to stay up there. The last one really throws them for a loop because they're like, that's not slope-intercept form. That's not y equals mx plus b. That's mx plus y equals b. It's not something we learned. So I'm like, okay, well, if it's y equals mx plus b, the y should be on the left, the x and the b should be on the right. Well, the y is on the left, the b is on the right. What is on the wrong side? The x. Well, how do I take this away from there and put it over here? Let's take it away. Subtract the 2x. Cancel it out. Now all I have on the left-hand side of the equation is y. Do I put the mx or do I put the b first? Put the negative 2x. Bingo. That is the equation that we're going to be graphing here. Oh, right here. So at this point I usually say, hey, try it out, see how well you do. Some of them do really good. Some of them are like, it's close to the bell, so they don't really do much. But we'll see how it goes. I'm assuming you've paused the video and you've tried it at this point. So my y-intercept, which is where we start, is going to be at 0, 4. And my slope, which is how we move, is a negative 2, which means I move down 2. And any number is understood to be over the number 1. Now in this case, it's always over a positive 1, because if I make that 1 negative, I'll end up with a positive slope, because a negative makes a positive. So I know it has to be a positive 1. So move down to right 1 from that value. Let's go ahead and graph it. This one I'm going to do a standard 5 by 5 by 5 by 5. The other thing I got that was weird on this one was that students were not doing the down to right 1. They were doing up to right 1. Not really sure why. Some of them were just doing something else entirely, where they were starting at like negative 2, 1, and then they were getting those parts confused, but only on this question. They weren't getting messed up on any of these, just on this one. Again, not sure why. Okay, so start out at 0, 4. Okay. I move down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. Connect these with a line and label your intercepts. And that should be about it. So there's my line. Intercept number 1 is up here. Intercept number 2 is right here. Hey, they're both on points. 0, 4. And this is on 2, 0. Bingo. So that's that. So let's take a look at homework. So I'm going to pause the video real quick. Let's take a look at the homework questions. Okay, so tonight what we're looking at is we have the homework for 3.6 is going to be on page 143. We're looking at number 13 through 20 all. Okay. Now, every single one of these is going to be graphing, so you're going to need to do it on graphing paper. Please make sure that you have some. We give them out in class. Otherwise, a lot of the kids at this point should have them, but all the homework should be on graph paper. We're not doing sketches, okay? If it's on regular notebook paper, it's not going to count. We do graphs on graphing paper. Please make sure we do that. Now, some of the students, periods 2, 3, and 4. So if you are period 2, 3, or 4, we also have an additional numbers 21 and 22. Okay. Outside of that, this is all going to be due on 10/22. That is tomorrow, which is going to be Wednesday. Okay. After that, we're going to be jumping into a few other types of graphing. Otherwise, I hope this was good. Hope it was a little bit of a refresher and you remembered everything that you were supposed to be doing. Like I said, I don't expect too many issues over this section. If you have any questions, always let me know. Take care, and I'll see you tomorrow.